So again, welcome everyone to our session today. We will be talking about using ARM for greenhouses, any sort of controlled environment, the various studies. As kind of an introduction, of course, most of the examples I give in a lot of our sessions are, just the uh, fungicide type of example, just because that is kind of where ARM started. We started in crop protection, but grew the software to cover really all aspects of the agrochemical research. And so, it's used worldwide. Really, the flexibility of it has allowed it to grow for all different types of research. So, although greenhouse studies have, really some fundamental differences in how they're performed and what is happening within them, as opposed to the field studies, that we're typically giving as our examples. We're going to show how you can still use ARM for those types of research. The structure is actually more similar than you would maybe think offhand. And so hopefully that's kind of our goal today, is to highlight that'll work. So I'm going to try to have couple of example ideas of experiments to work through. That's more in this realm. But definitely ask questions throughout if you do have examples of what you're doing, if it doesn't quite make sense to what I am saying, or just want to know in general how that could be incorporated. Because that's really the goal here, is to show that just with a couple of connections of you kind of translate this into that. Well, it's a field study here, but if you think of it this way, suddenly you're good. We're cooking with the software in this other type of research. So that's our big goal today, is just to make those connections. Of course, if you do want to reach out to your local support, if we don't have time today, or you're watching the recording, we would love to do this with you and have more time for questions and examples and talk through it all. We're more than willing to add items to the lists that you find in ARM as well. That's how we've grown and able to cover more different types of research, just hearing about what's done out there in the industry. And a lot of times it's not too hard to add another rating type. It's not too hard to add different things and lists to be able to support and document the various research that's going out there. So just hoping to write kind of a open check there in some regards, as to connecting up and getting things working for your group. All right, so I'm going to toggle over to ARM. And my goal today, really just to create a new protocol and just step through all of the pieces, and kind of at each step, we'll talk through that conversion factor, if you will, of what's different compared to a field trial. What would you do differently, or some of the options that are already there that are ready for these types of studies. So I'll just create a new protocol. And right off the bat, let's just go into protocol settings. Kind of the first one, even before we look at the actual settings, just to call out in the middle of the screen, the study definition. Kind of a technical term. Really, it's just the construct of your trial, all the fields that go in it, what it's going to look like. And by and large, almost all the time, this G-all, the standard G-all, as we call it, is what is used. But the other option here would be when you're doing a variety study, that mostly when you don't have any chemical being applied is kind of the biggest trigger there. If that kind of fits your type of research, no chemicals involved in any application, kind of all of those sections and complexities that ARM can support are kind of stripped away in this seed version, this study definition. Other than that, it's pretty similar. There's still treatments, there's still assessments. We've got, a lot of those fields, but some of them are just named a little differently to fit the terminology used in, strictly variety studies. So that would be kind of one call out there. If you have any chemicals involved, even if you are doing, studying varieties, but there's some chemical applied to the seed or anything like that, you probably still are definitely better off with the G-all. So I try to stress kind of just the chemical part is really actually the biggest difference between those two. So in most cases, that G-all, and that's what I'll use today. That's been generalized the most. It has kind of everything available to us, even if we need to ignore some of it. Okay, looking at some of the other settings here on the general tab. Of course, replication's probably still occurring for that research. There's nothing too different there. I think one hang up here might be that treated plot size. So in a field research, that's kind of a big deal to figure out what kind of area out in the field that you're utilizing for each plot. And that probably matters for yield conversions and making spray applications and all sorts of things. So really, really important right at the very top here. In a greenhouse, it is a little bit different. So just depending on if, once again, going back to the treatments or your applications, if the size matters of the area of your plots, we do have the smaller sizes. So you could still document the size of your pot or your whatever container that those experimental units will be. We do have inches and centimeters, so you can get smaller and still get that right area of a plot. If there's really no calculations, nothing that would matter, you can kind of the workaround I could recommend if it doesn't make any sense. For my study, it doesn't even make any sense that there is an area for my experimental unit. Usually I tell folks just do like a 1x1. Then anything that ARM would try to do from a calculation standpoint, it'll be simple, it'll do it, it won't really matter. It'll be a 1x1 simple. If they really just, if you would have the urge to leave it blank, I think ARM will get mad at us if we were to try to leave it blank and move on. So just a 1x1 is kind of the easiest way to just say, yeah, this number doesn't really matter. We'll just give it something so that way it's happy. A good question here, is it possible to define that the pots are circular? We don't currently have that. So I would think maybe just trying to approximate your area, right? Maybe that's probably what I would do. So if it was like a 1-inch circle, boy, I'd be tempted to say it's like 1x3, just just in case I needed any area, that would roughly get me there, right? Whatever the, yeah, something like that. Again, I think if the area matters, go for it. Try to just then replicate the area more than the true size. Otherwise, a 1x1, if the pot is a 1-inch circle, that maybe that's what I would do. Does take just a little fudging here in the size. We'll see in a little bit that we will have an area in the site description or the protocol description where we can be a little more detailed in what this experimental unit really is. I think we do kind of have a spot there where we can kind of designate what that pot size is, and we'll see when we get there if there's something about being circular or not. So right here, it's really just about the area. Like I said, mostly it's that engine for calculating product if the rate is based on an area size. So if that really doesn't even matter, the ones is a nice way to just kind of get around that. Everything else here, doing GLP or GEP, that doesn't change. Those standards don't. So those all should be kind of the same throughout anything. On the Design tab, pretty similar thought process here as far as just selecting your experimental design. Doesn't matter where it is, all of that analysis is the same. I think, of course, in general, the RCB is probably less of a given. In field studies, that's what most of them are, or at least very, very common. For a greenhouse, you probably, you've got a lot more control of your of the pots, of what's going in there. You don't have a lot of this just dealing with what could be there in the field variability. You have more control. So the CRD is probably more common, if I had to guess. So we do have the completely random design available as well. That would make more sense. Now we don't have to block things out. Treatments can be distributed wherever across the whole area, in quotes, of the experiment. And then the same idea as well with our multi-factor designs. So essentially here we have your factorial RCB or a factorial CRD. Basically, that's the a completely random design with a factorial arrangement of treatments. Would be kind of the longhand definition of that option here. So when you're doing, maybe the structure of your treatments that you're investigating is you've got multiple factors that you're looking at, and then you have different levels. I want to test every combination of these two ideas. I think the example that I use usually here would be maybe I've got 4 different concentrations of this product that I want, and then maybe I'm going to apply those to 2 different varieties. And so I want to test all of the possible combinations of the 4 different concentrations and the 2 different varieties. So that would give me a total of 8 combinations in total. So that concept is the factorial arrangement, a factorial selection of treatments. And then the other half of that question is how are they, what is the arrangement then when we actually go to put the plots down? Plots, again, in air quotes. I'll keep using that term because it's so ingrained in my brain, but really they're experimental units because we're not out there in the field. So then that would be where, CRD, if I don't need to block at all because all of them will be on a tray and there's no reason to think that there's some inherent gradient that I have to encapsulate, then I can just put them wherever on that tray and they can be spread out. If there is any sort of pattern to it that I want to capture a gradient, maybe if I have to have multiple trays and the growth chamber where they're going to go at, I know that there's a slight difference in the top tray versus the bottom or something. If you're aware of any sort of gradient in that way, that's where then that RCB becomes useful. Yeah, great comment there about how common that CRD is in those greenhouse. You've got this homogeneity that you can bank on, whereas in the field studies you don't. You don't have that in a field. So the CRD is very much more useful there in some of these cases. So I think that'll be the example here. I'll just kind of step through and put this in somewhat quickly. So I've decided on factorial CRD, and then I can describe, I think concentration would be my primary, my factor A. And I think usually the setup would be that those concentrations, if I do have multiple trays, or maybe kind of the trays will have to be in a different location. There is also the option for a split plot. So I think that's usually what I use here then. So I'll want that kicks in when there's some sort of grouping mechanism that I may need to have in place. And so I think usually I'll have maybe a different tray for each concentration level, and then that way they can be a little bit separated, so you don't have any cross contamination or anything. Each tray then has that one level of concentration that's going on there, and then like I said, I've got four different levels. Um, well, medium, high, really high, or vice versa. And then there's the variety that I have two different varieties I want to test to see if there's any differences in the performance there. So that split plot still comes in handy even in these types of designs. All about arranging those experimental units and how those treatments get distributed. And then things like the treatment tab application, we'll come back to those once we start filling some things in. And the layout is all about your randomization as well. So let's proceed then into the protocol itself. I think I'll start in that protocol description. So in the first section here, the trial establishment guidelines, there is about halfway down in the site and design. Again, we kind of replicate that treated plot size. This value is directly the same as what we had in settings that we just talked about. But there is a spot here for experimental unit. So we have the ability to be a little more verbose about what exactly it is that we have in this study. What is our experimental unit? And so there's quite a lot of different options here. Again, just to be able to give that definition. And so there are a variety of different pot type of options here. And like I mentioned at the beginning, if there's something you're using that you really would want documented here, but you don't see it, pretty straightforward for us to add to a lot of these lists to get the type of thing you would want documented. And I'm not sure, some of these different pot sizes, if it's super important to document the difference versus we have a generic one as well of just it is a pot of some sort. I was kind of looking to see if we had anything about that circular versus square. We really don't, do we? It might be just kind of assumed, to be honest, though. I don't know how often pots are rectangular versus circular, but at any rate, this would be kind of where you can go to give a nice, clear example. Let's go back down to the pot, and I'll just choose that there. So that just gives this nice explanation here in the site and design to explain a little bit better than just kind of cramming something in. We make do with what we have with the width and length. Oh, in the volume. Okay, so that description might be in the volume. Yeah, there wasn't much here. Let's see. Would that be in like the application? I'm trying to think of where that field might be. But yeah, the amount of volume in a pot, that would make sense that would matter as well, potentially. Um, yeah, the volumes there. So again, if you have things that don't quite fit and you don't really find a good one that won't work at all, definitely let us know. We can get things in there. Let's see, other sections. A lot of these are pretty general: contacts, objectives, crops, pests. Um, I guess a general comment would be, of course, as you're looking um, through the screens, and there's quite possibly things that just don't make any sense in in a greenhouse study. We're not doing any tilling, for example, or whatever. And it's true really of any research you're doing. ARM has so many different fields to cover all sorts of different types of research. This is where the concept of the view really is powerful. So I'll just pick on this tillage type, for example. I'll never ever in the research that me pretending to be a scientist in the greenhouse, I'll never need this field. I'll never fill it in. I simply can right click on that box and hide it from my view. And that just takes it away from the screen so I don't have to look at it. It's possible to always bring it back. We have this list of hidden fields in the corner, so I can always pull that back if it changes, but I can go through and really clean up the things that I'll just simply never need to use. And maybe that plot area, that just never matters to me. So I can just hide it, buffer zone, hide it. You can see it'll shrink down the screen, um, which then also follows through to my reports. Um, so it can just simplify what I look at. I don't need to see all of these boxes. I don't need to see the background. Um, It'll just slowly but surely simplify what you see across all of the different sections of ARM. And the advantage is just, if I don't need to use it, I don't need to see it. So why not remove it and make things simple? And if I do need to toggle, so maybe in the winter time, I go to the greenhouse, I'm doing some greenhouse studies, but then we transition, and then I also have to juggle and do some field work. You can save the view. So when you get it all crafted to look the way you want it for a particular type of study, type of research, you can actually save that and give it a name and then toggle between different named views. So that can be done if I just open up my view options here on the properties panel, or tools options will get you here as well. When you have, this is just kind of the list of all the different sections in my protocol description, and then I can see underneath that which fields are visible and which are hidden. So essentially, we're just going to save this list of all of my selections of what I want to see and what I don't. I can save it to a file. And so I can, maybe I'll just save it as my greenhouse studies view. And then I can have a longer description, but I named it pretty clearly. I know this is what's useful for that. Then I can always start back up again when I'm in my field studies. I can turn on all of the fields and do the process again of eliminating ones that I don't need and save that to a named view. And then it's just a matter of, if I go over here on the right, there's this views section, the named ones that I've created. I click on greenhouse studies. You can see it immediately switches back to hide those fields that we had gotten rid of before. So it's easy to switch back and forth. This has my default, more of them. And again, this is across all the different sections of the protocol description. And the same idea can be done on the treatments editor, on the assessment data. They each have their own view because it's a different set of fields to choose, but the same idea that you can make, in a way, customize what ARM looks like depending on the type of study that you're in or the type of research that you're doing. So I think that's really powerful for just about anything, but especially um, for this like totally different world that we're talking about today compared to a field study. Let's get rid of all the stuff that's kind of specific to those studies and only focus in on what matters for this. Okay, if we make our way over, I think the next section that would matter a lot would be our application. Then, method, timing, placement, the different things you're doing should just have the options in the list, right? Just like those other ones. Kind of the benefit of ARM, that structure of there is some sort of application that takes place and I need to document what it is I'm doing. That's really no different. Just the choices that you are choosing from the list would be different, but nothing too crazy there. Down here at the bottom, we've got those as far as calculating the amount of product you'll need when you make those applications. Kind of the biggest impact here would be that application amount and your mix size. I pop open our mix size calculator. We can start with the application amount. And actually, let me close that. Let's look at the application amount list from this screen, because then we get that nice description as well. So all of the different application amount units that we have available, kind of nice to see the description too of what they are. Sometimes they kind of hint a little bit about what they might be useful for. I think ones that would be impactful here, something like the milliliters per liter, so that if you're applying product into potting soil, for example, that'd be the type of application amount unit that you'd be looking for. There's milliliters per item. So that's useful if if your product rate is per plant, for example, then that per item kind of matches that, right? When we try to keep it flexible, we don't want to have milliliters per plant and then milliliters per tree, milliliters per everything. So we tried to generalize the term. But in that rate, if it's per plant or something like that, then that'll match up here for your application amount. Worst case, kind of depending on the calculations you're doing, sometimes that application amount isn't directly needed to perform a calculation. A lot of times that application amount is used to inform and calculate a mix size. And then we can use that mix size as actually what is put into what ARM uses for product calculations. So if you can't quite find the right thing, or maybe it doesn't totally matter the application amount, that I usually recommend putting in a 0. So if it's not really used, we always have a certain mix size, and that's all that really gets included in calculating a product amount. Just putting in a 0 is a good way to have something filled in, but then it's kind of clear. There's nothing here, nothing to see, it doesn't matter. And then you could put in the mix size. So the mix size calculator here is trying to take your application amount and your plot size in order to calculate the appropriate mix you would need. So might be totally irrelevant, right, for these types of studies. Again, if you're not going per area, it doesn't make any sense at all. Some of these other units, it won't. So I think if we were like mils per mils per item, nope. Some of these, it won't, it doesn't need it. There we go. For, if it's like 100 pounds then they're very clearly not a per area type of application. And so we get rid of that calculation anyway, because there is nothing per area about it, for example. So definitely, it's possible to ignore this if it really doesn't make sense what it's trying to do here. You just toggle over to the user-defined mix size, and we can put in whatever amount we're doing. And again, lots of different options here for the mix size unit as well. So just like before, if you're per plant, we use that same general units terminology here. So if you wanted to know how much am I going to need to mix up to apply to 6 different plants, you would just put in 6 units as the mix size there. And there are some here for like, cubic meters of mix. That can be if you are treating soil, things like that. We have units for those types of things. So this kind of where we can try to incorporate a volume. That is one question sometimes that comes up back when we were looking at that experimental unit size. And yeah, we just have a width and a length. It's like, well, that's not really what we're doing. We're actually, the experimental unit is an area, it's a volume. Instead of a flat two-dimensional area, it's a full volume. So we don't have a spot to define it as a volume, but when needing to create a calculation for your amounts, then we can at least get a volume as defined in your mix size, for example. So that's kind of the workaround there, is to define it, the volume of how much you're going to apply into that mix size. And then we have product rates, which we'll get to the treatments editor here soon. We've got product rates that will also support that concept of applying it to a volume, not just an area. A good point here, comment on that. Maybe your pot area, if you using that surface area would be a good way, just again, documenting wise, maybe none of the actual calculations matter much, but to document that surface area of the top of that pot would be a good way to put something in there that would make sense. I like that idea. So in sum here, on those kind of messy, trying to cover the different scenarios, it really is. There's a lot of possibilities with ARM. A lot of it's just, this process here is just figuring out how to make it work, kind of knowing, and that's where we can help, knowing kind of what pieces of information ARM is going to pull from in order to get calculations, to get things all documented. We can kind of help find those pieces and make it match. I think the rest of these, crop stage, pest stage, site information, equipment in general, that's trying to be pretty generic as well to support different types of research. So nothing else here in that protocol description. The rest of it should be hopefully somewhat straightforward how to match that up. So moving on to treatments. And here I did select the split plot design. So I'm in this multi-factor design setup. And that does change just a little bit how the treatments editor looks. So that's just because of that study design that I chose more than anything. So we just have the different sections of the treatment editor here just to encapsulate the factor. We'll describe the different levels of our factor A, which was our 4 different levels of concentration, then describe the 2 varieties that we're going to study, and if we did have any other treatments that we wanted in our final list that wasn't part of this 2x4, then that's a comparison treatment at the bottom. So the example here I'm going to use is one, I think I picked out fusarium, that fusarium concentration study that we had encountered in support that, to the unknowledged person that I was, had no idea how to tackle it at first. And then as we kind of worked through the requirements, got a good system down on how to do it. I'll just kind of carry that one forward here to give that example. And talking through this one here, I think our very lowest level rate was actually to have nothing. So we do want that untreated check around. So in a sense, that'd be like a 0%, 0% for the concentration, right? Not actually doing anything at all, and it works well. We'll just call it 0% just to fill it in. And the general approach, I guess, before I start filling it in, we found is that we have a kind of a base of starting concentration. We put that in as the formulation for our product, and then the rate we expressed as a percentage based off of that starting amount. And then we utilize the mix size, in order to get a prod calculation. The mix size is the size of container that we were using to make the dilution. So that way we can get these different levels of dilution based on the main starting amount that we had. And just to make the numbers really easy, I think 10,000 CFUs per milliliter makes a nice round number to divide out. So let's see, CFU. So, 10,000 CFUs per milliliter is kind of that base amount, right? And then we want to dilute that to different levels. That's what we're testing is at what level are we kind of maximizing the performance that we want to see. And I think I'll just take liquid as the formulation type. I think I'll just call these low, medium, high, probably kind of generic. And we do the exact same thing. So let me just copy these and paste them. So we have that same base formulation amount, and then we just have these different levels, 10%, 50%, and 75%. Again, this is just one example for sure. We can help try to find, but there's tons of different units. There's a lot of different combinations available. So we can kind of help you match up what you might need. There's just so many different combinations. One of the big things to make sure if you're struggling to find, like the product rate, there isn't a suitable unit, make sure that you fill in the formulation type. And the key thing for ARM is that when you fill in the formulation type, it then knows what the formulation state is. Is it a dry or is it a liquid? And then is it going to be undiluted or not? Matters a little more just for the product calculation, but that does get involved also in some of the unit conversions. So once ARM knows the basis of what type of product this is, how it gets applied, then it's able to create a rate unit list or the other rate unit list for that type of product. So make sure you get that form type in before you're looking for the right units. So that way it's giving you a sensible list to look at. And then I think I'm just going to make up, I think the idea was that you have a variety that is resistant to the fusarium and then one that is susceptible, if I can spell susceptible close enough. I won't worry too much about the details of those varieties. But that was the basic gist of that research to be able to compare one side to the other and then the different levels of that. I guess to tie the bow on the idea of that multi-factor is I can, under tools, I'll multiply out the treatments now that I have filled it in. So the idea is, if you haven't worked with multi-factor studies in ARM before, this is going to combine to take and do kind of the multiplication, right? So what I want to have in the end is a trial that has 8 unique treatments, an untreated with the resistant, the low level with the resistant, medium with the resistant, all the way down, and then another 4 of the untreated with the susceptible, low with the susceptible, a total of 8 all multiplied out. So if I want to preview that while I'm in the protocol still, this command to multiply out treatments is available to me. And here it's first asking for me to save this trial before we convert it, or save this protocol before we convert. And I'll just throw this on my desktop here and just call it my webinar protocol. Okay. So there, now ARM did that multiplying just to show kind of a general, a more normal looking treatment list. If you're not doing the multi-factor design, this is probably what you're used to seeing in the treatments editor. A little more straightforward list of 1 to 8, each different treatment and all of their components available to us. Okay, a couple more topics for us. To move on to the assessment data section. This one probably has the least, I think, to talk about. There's not a whole lot different, I think, in the assessment editor for greenhouse studies. I think in general, the assessment editor is quite generic in the sense that, you know, there's always all different sorts of assessments and types of assessments that get done. Even in a single research study, there might be a lot of really different types of things you're doing. So it's already, I think, pretty well understood how general and available everything is. Maybe worth just talking about subsamples. Kind of the key thing I think that pops out in my mind that maybe, I don't know if that would happen more frequently in a greenhouse, maybe not necessarily. But just to point out that if you are doing subsample work, there's a few different fields. I think the third one I'm looking for is hidden. Yes, the reporting basis. So if you're doing work where there's more than one rating per experimental unit, that would be a subsample. So some sort of and maybe I'll just say five subsamples. So there'd be 5 different values for a given experimental unit for one assessment. That's really kind of how you create multiple values for a single plot. These 3 fields here, your sample size, collection basis, and the reporting basis, those make up kind of a very thorough way to describe the system or methodology for subsamples. So I like to just point those out depending on how complicated or sophisticated your sampling method is. You might not use all 3. So you don't always have to fill in all three necessarily, and it just depends on the system. And I think it's probably most helpful just to point out if you do if you look under help, there is a list of references, just PDF documents for various topics. And one of these here is describing subsamples in assessment data. So it's just I think it's just a 1.5 page document that, again, just talks through, these are the 4 fields that really we're really looking at, and it tries to explain how best to use those. Because the definitions of them are a little weird. A lot of these fields originated with SART, um, and their terminology was frustrating at best of how they chose to define the like what does sample size mean? And the tooltip says it's the number of samples per collection basis numerator. And for the life of me, I can't map that in my brain to how that makes sense. And then the collection basis is the optional denominator for your sample size. I really struggle with those definitions and making that relatable. So that's kind of why we have this document here that gives few different examples from no subsamples up to just 20 fruit. What if you need to select so many fruit per branch, things like that, showing different examples that pull in those different fields. And hopefully that can kind of help build up a working definition of those fields. Because I know personally, I really struggle trying to explain what those do, at least without examples. It's just really hard to get a definition going on those. And I think that's about it for the assessment data section. So then I think the next one would be the trial map. So I'm going to go ahead and create a trial in order to see that trial map. All right, and that's a little hard to see. I'm going to get all the way into the trial first. So I'm going to accept that map, and then we'll come back once we've established the trial file here. Yeah, I'll just save it again. Okay. Coming back to the trial map, and it is a little hard to see, partially because I'm in a multi-factor design. So as I zoom in, you can kind of see some of the reason is there's a lot of information being crammed into each one of these boxes. And that's because in addition to the plot number and the treatment assignment, because I'm in that split plot, that multi-factor design, we can also show the different levels of the split plot. So we could turn that off for the moment to at least see a little better the overall idea of what we see on the map. So with the trial map, the idea here wouldn't be so much the arrangement of the plots out in the field, translating that into the greenhouse. It's more about the arrangement of maybe the pots on the tray. Might have to use a little bit more imagination might be required because of that. But we can certainly kind of still manipulate this map to try to encapsulate how the locations of your experimental units relate to one another, because that can be impactful for your statistics. You were to do any spatial analysis. I don't know how common that would be in the greenhouse realm, but even just to um, try to document as best we can the way things actually are in real life, right? And how do you translate that into this map, which is obviously going to be somewhat limited. Um, Actually, I just noticed I've got my true scale on. That might be hurting us a little bit too. There, it fits a little better here. So yeah, a great question here on that non-rectangular shells that you're dealing with. Um, I think the biggest thing offhand would be to go into your settings. The block size is probably the biggest bang for your buck, if you will, as far as just crafting the overall shape of this map. And this is true in field trials as well. That this is really powerful. If I select 4, then when I re-randomize, it fundamentally kind of changes the shape of that map. And probably if your shelf is not rectangular, this we can probably just get you somewhat close, and then we can move plots around a little bit. And I can show that next. But just real quick here, we still have the replication that is needed in this design, but now instead of having them extend all in one row, I've split that up. We've limited down. Well, I can only fit 4 in this example in a single horizontal row. So then it becomes kind of stacked up. So that would be a way to start to mold the shape of things to match what you would need. Again, if you're not a rectangle, can't quite get it perfectly, there's this auto select for move. And if you turn that on and then choose a I'll choose the experimental unit here to show that. Then when I click on a plot, I can move it. If I need to make room, so if I kind of want an extra column over here, I can drop it off kind of in this empty space and make more room. So I have no idea what kind of um, unusual shape you might be dealing with, but I'll just make up something here. Um, so we're just kind of dragging around these experimental units to match a grid. Again, maybe it's not perfect, but try to get close. If I want to, if I have these on different shelves, maybe like we had said, each of these replications are on different shelves. Uh, don't really have an explicit box you can draw on here, but maybe I could insert empty rows as just a way to kind of visually represent maybe what would probably be a different shelf, right? So it's going to take a little bit of imagination maybe to find a good methodology though to be able to most the get as close as you can to matching what's in real life, even if it's a little bit imperfect. There is down here at the bottom, there's a trial map comment. So an open text here, that might be really useful to help bridge that gap on what, so if someone else opened this up, what am I looking at? I thought this was a growth chamber. Um, being able to translate that, an empty row, it equals a new shelf, or, whatever uh, whatever instructions you might need to translate a little bit what you came up with to help um, make it real, right? So that's a good question, and for sure, same recommendation. If you're stuck, not quite sure how to do that, always feel free to let us know. How can the map be saved? It's happened that the map reverses. Um, once you've made changes clicking accept current is going to save the changes we've made back into this trial. So that should, at least in the concept of saving to this one trial, that would be how you'd save the map. And then it remembers where everything was at. So I don't know if you meant that within a trial it like reverted back. If you accidentally clicked cancel, then that would abandon any changes. So that'd be the simplest way that you could potentially lose that map. Sometimes the drag and drop, if there's a lot of plots, that dragging and dropping can be a little slow because it's refreshed. It's got all of the different plots to deal with. So just one other trick that might be useful to make the map how you would want is the map really is a visualization of what is here in the assessment data section. We have rep block column, and then you have the plot number and the treatment assignment. This really is the map. You have block and column create essentially an XY coordinate system for the map. So every plot has its own coordinate, if you will, of where 204 is. It's 5 over and 1 up. So that's really 5 and 2 in that case, right, is where 204 is at. So you can manipulating these values would manipulate the trial map and change the location of those plots, which can be powerful, but also dangerous, depending on whether you intend to or not. So by default, all of these values, they're in italics, they're locked. So I'm typing the number 2 on my keyboard, but it's not changing this value here. It's locked. So you would explicitly come over here to unlock those values if you were to change them around. You have to be a little careful though, of course, because I can't put 2, 3 here if there's already a spot that's 2, 3. So there's a chance I break things and things go poorly. So you kind of want to be careful. So usually what I would do is there's a copy button that basically grabs all of these together. And then you can go into something like Excel and I'll paste in so I have all that information. Then I can make my adjustment. Sometimes if there's kind of a systematic way, I can imagine you can like calculate out where they should be. And so if I were to, let me just swap around something, maybe the 2, 4, and move that up. Something like that. We'll just move this plot around, see if there's one that going to cause a problem. If I move that around 2 and 4, and there's an empty spot. 2, 4. I'll just make it simple. Let's just move 102 up one spot. 104 should go up. That's exactly what I was doing. Move that up one spot. If I copy then this list, and as long as I have the headings available too, so ARM knows this is randomization details, then if I paste into any empty assessment column, it will detect that the randomization is different than what is in this trial, and it can change the map accordingly. And of course, I messed it up, so I wasn't paying attention. And you can break things, so that's the concern there. So you have to be a little careful what you're doing. And clearly, I looked at the wrong plot or something and switched those around. But there's already one that is 2, 4. Yep, there it is. So I messed that one up. Let's move that to 1, 4, and then maybe it'll be happy. Then the map should look the way we want it, with a slightly different location of 104 and 202. Yeah. So I had my coordinates mixed around, so I was looking at the wrong plot, so we switched those two around. Obviously, a lot easier to do the auto drag when you have just a few plots. but just wanted to show that there's some flexibility there. And I've shot past our time here, so that was our hour. Hopefully it gives you an idea at least of the differences here. ARM is able to work with some of these studies, just takes just a little bit of finagling and making things work. So again, feel free to reach out to us if you're having any troubles trying to get those conversions, how to translate it in. We'd love to help and maybe learn a little bit about other types of research, and we can always grow ARM as well to support some of those things too. So with that, we'll sign off here. As I said at the beginning, kind of the last webinar for the season here. We'll pick back up in the fall with usually more summary themed items. I should say fall in the Northern Hemisphere. It depends on where your research is. It might be kind of totally the opposite. So at any rate, thanks for your time. And hopefully we'll see you again in, I guess, maybe a few months. So.